and welcome to an algebra tutorial video learning about solving systems of linear equations using the elimination method. So the elimination method is another way of taking a linear system, two equations like this, and looking to try and find where they intersect. What is that point, the x and y values, that when I put them in, both equations end up being true. So I've got kind of our checklist of what we're going to do. These are steps that we're going to do, and we're going to just go through how the elimination works, make sure you guys understand it, and have a good sense of where we're going. So this is an easier problem, so hopefully it'll make sense as we do it. Okay, so the elimination method, the first thing you want to do is you want to make sure that both equations are in standard form. If you remember standard form, that's the ax plus by equals c. So all it helps us do, you can see here we got 3x plus 5y equals 18. That's in standard form. And here I've got 1x, which is x minus 5y equals negative 2. That's in standard form. And mostly standard form, it just helps us line up our x values, line up our y terms, x terms, y terms, and line up the constant terms, because we're going to end up adding these things together. So there we go. We've got them all in standard form. Step one is already done in this problem. If we didn't have that, we would have to do some rearranging to get them into standard form. All right, step two, multiply to get opposites. So the key idea here is, if I look on step three, I'm going to add my equations together. I want to get opposites. By opposites, I mean things that I'll add together to get 0. So right here, I've got a good example of opposites because I have a plus 5y, but then the equation below, I have a negative 5y or minus 5y. That's exactly what I want to have happen, because when I add these two together, when I add straight down, I'm going to have a 5y plus negative 5y. Those are going to turn into 0. And that's what I'm trying to do. So I'm looking to see if I have opposites, 3x and 1x. These are not opposites down here. So if I added them together, they'd add up to make 4x, but they're not going to cancel out or turn into 0. So look to see if we have opposites. If we don't, we're going to have to multiply or do some rearranging in my equations to get opposites for variables. But right now I've got plus 5y and I got negative 5y, so I'm feeling good. I've got that. I'm going to take away my boxes there and we check mark. We have some opposites. Okay, now we can go ahead and add our equations together. So again, just like substitution method, I'm trying to take both equations, combine them to make one equation that I can then start to solve. But instead of substituting one equation in for another, we're using the addition property. So I'm going to take these two equations, and essentially I'm taking the top equation, 3x plus 5y is equal to 18, and I'm adding the same thing to both sides. Since x minus 5y is equal to negative 2, if I add x minus 5y on the left side and add negative 2 on the right side, I'm adding equal things to both sides. So my original equation is still good. It still fits or satisfies the original problem. So let's see what we have now. So if I combine like terms, 3x plus 1x, I'm going to put that invisible 1 there to help make it obvious. That turns into 4x. This is why sometimes it's called the addition method. Plus 5y or positive 5y plus minus 5 or negative. Now I've got my opposites. Those are going to turn into 0. They cancel each other out. They're opposites. I like that. Equals, now I'm adding on the right side together. 18 plus negative 2 is going to turn into 16. Okay. I've just added my two equations together. Check, we just did that step. Now I want to make sure, just double check again, I can add any equations together, but the whole point of this elimination method is to simplify it. I want to not have x, or I don't want to not have y. I want to get rid of one of the variables and solve for the other one. So just double check, is one of your variables eliminated? In our case, it has been. We got 0y. They got eliminated for the y's. So what I end up having left then is 4x over there equals 16. And this becomes an easy equation to solve, right? So let's solve for the other variable, the one we didn't eliminate. I'm going to divide both sides by 4. And it looks like that x should equal 4. Okay. Again, what are we doing? We're trying to find that intersection point. I could go use a graphing tool. I can put both of these equations in. I like using the desmos.com calculator. It's a free online one. It's a great one. But then you can actually visualize what the graphs of these two equations are doing. But I know that they're going to intersect at an x value of 4. I still need to find the y value, however, so I solve for x. Now I've got to back substitute step 6 and solve for the variable that I eliminated. I got to solve for y. So I know x is 4, but I have two equations. Now that I know x is 4, I can use that to help solve some other stuff. So I'm going to use the bottom one here. X minus 5y equals -2, but I'm going to put 4 in place of x. So we've got 4 minus 5y equals -2. I just did my back substituting. And now let's solve for the eliminated variable. Let's solve for y. So I'm going to subtract 4 from both sides. That turns to 0. Got -5y equals -6. -2 minus 4. And if I divide both sides by -5, it looks like y equals negative divided by negative turns into positive 6/5. I could rewrite that as 1 and 1/5, which is also equal, if I want to use a decimal, to 1.2. So different ways I could write it. I'm going to go ahead and use a decimal here. My y value when I solve for it is 1.2. Okay, now we just solved for the eliminated variable. I've got x, I've got y. There's one other step I didn't write here. It's kind of a critical one. We should always check our work. So again, I could check it with a graph and just make sure this point does satisfy where they intersect. Or I can check it by putting my x and y values not in the bottom one. I use this bottom one to find y, but let's put them both in the top one and just double check to make sure they work. So does 3 times 4, 3 times x, plus 5 times 1.2, does that actually equal 18? All right, 3 times 4 is 12. That's easy. Plus 5 times 1.2. Well, 5 times 1 is 5. 0.2 times 5 ends up becoming 1. So that just equals 6. And 12 plus 6 is 18, which equals 18. So it does check out. So I would definitely encourage you. You should be able to know as you're doing these systems of equations, as you're using the elimination method, you should always be able to check to know if you solved it out correctly. So there we go. We've just got the solution to this system. When x is 4 and y is 1.2, it satisfies both of these equations and is the point of intersection.